In this video, we're going to look at another example of a tricky question where we need to use a previous answer to form a new binomial distribution. Let's take a look. It is known that in a large population of ladybirds, 40% of the ladybirds have 8 spots and 20% of the ladybirds are yellow. Given that the number of spots and colour are independent, find the probability that a randomly selected ladybird is yellow but does not have 8 spots. Alright, so since we've got these two categories here, whether they have 8 spots or not and whether they're yellow, we should set up a Venn diagram. That seems like the perfect tool for us to use here. So I'll draw my Venn diagram. And it does say that they're independent, and since they're independent, we can multiply probabilities. So the probability that a ladybird has 8 spots and is yellow is the probability that it has 8 spots multiplied by the probability that it's yellow. So that's because it's independent. So we need to multiply 0.4 as the probability it has 8 spots, and 0.2 is the probability that it's yellow, and that's 0.08. So that goes in the center here, 0.08. And I haven't labeled these, so I will do that now. So this is represents them having 8 spots, and this represents them being yellow. Now I know that 40% of the ladybirds have 8 spots. Well, I've got 8% in here, so 32% is left over, so that better go in this section. And 20% are yellow, and 8% are already accounted for, so I've got 12% here. So what's left on the outside? Well, I've got 20% here, so that plus that is 0.2, plus that is 0.52, leaving 0.48 on the outside. So there's a completed Venn diagram. So the question is, find the probability that a randomly selected ladybird is yellow but does not have 8 spots. So yellow but not 8 spots is these guys here. So there's my answer, straight from the Venn diagram, 0.12. Now, 16 ladybirds are selected. Find the probability that at least 3 of them are yellow but don't have 8 spots. So this is a binomial question. It's binomial because I've got 16 trials, the ladybirds, and they're either yellow with but don't have 8 spots or not. So write down my distribution. So it's the number of ladybirds that meet that description is binomial, has a binomial distribution. I've got 16 trials, and the probability in each case is 0.12, because that was my answer to my previous question. Remember, my previous question was about the probability of ladybirds that were yellow but didn't have 8 spots, and that's what I'm looking for now, yellow but don't have 8 spots. And now the question is, find the probability that at least three of them meet this condition. I've written 8, at least 3. So useful to write out a little list of numbers. So at least 3 means 3 or more. So what isn't it? Well, it's not less than or equal to 2. So that's 1 minus the probability of x being less than or equal to 2. Okay, now this is a good stage to go to the calculator. So let's pull up the calculator here. And I go to my distribution, so menu, distribution, it's binomial cumulative, variable, and it's less than or equal to 2, so I put in 2. N is the number of trials, which is 16. P is 0.12. And we get 0.7001. 1 minus 0.7001. And that gives us 0.2999, which we could probably get away with rounding to 0.3. Alright, that concludes our work on the binomial distribution. So I hope you've enjoyed learning all about that. In the next chapter, we are going to put it into action by looking at hypothesis tests. I'll see you there.